Anybody wants the weird experience of going to my YouTube channel and watching what's happening now a minute ago, or watching what happened a minute ago now, you can do that. But it just occurred to me I didn't do this last term, but I thought this would be a good discussion to have because there's going to be one asymmetric projectile problem on the test coming up, and you've only had, you've had one that Mr. Pennington calls asymmetric, but really there's some other asymmetric ones. So the first question here, what is an asymmetric projectile problem? Anybody know what I mean by that, or what Mr. Pennington means? Claire?
A projectile problem that doesn't like start and end at the same elevation.
Right, yeah, so a symmetric one would start here and end here, or start here and end here. So everything, the beginning speed and angle and the ending speed and angle are the same. The time up is equal to the time down. And I don't think Mr. Pennington, when he does these, when he's thinking about asymmetric, I think he would consider one, the shooting something horizontally off a cliff. I don't think he really puts that in the asymmetric category because that's kind of like half of a symmetric one. Although that would be asymmetric too. If you either shoot something up so that when it gets to its high point, it stops. That's like half of a symmetric one. Or if you shoot something horizontally and then goes down, that's half of a symmetric one. But I wanted to just go over the possibilities for what kind of, was the answer to number one?
Yeah.
It's just the starting point and the ending point of the trajectory are at the different elevations. And the next question is, how many different kinds of asymmetric trajectories can you think of? And then number three, I'm thinking about this ahead of time because I'm going to get rid of that. I'm just going to put a white screen up there. That way I can hear the people at home if they want to say something. I don't have to mute the projector, although it'll have a glare. So how many different kinds of trajectories can we come up with? What are some variables that can be incorporated into a problem? If I were going to make up a problem, like what are some possibilities for that problem? I had a little cheat sheet I wrote down a minute ago, but I've lost it. And then finally, let's make a problem or two. So I'll create, with your help, maybe a couple of problems that if people want to solve, you can solve later and I can go over tomorrow. But for now, let's see, I'm going to switch to this, which should give me boy, everything's laggy because I'm streaming. And I'll freeze that. So, and then switch to the camera so people here can see me right. And then maybe I can actually right there. All right, this is where I want to stay away from. This is where the big glare is. I should make a mark. Danger zone. So if I stay away from there, I'm good. So kinds of trajectories. I'll just draw these to get them out of the way. So if you have something that starts, something launched off the cliff horizontally, like that, that would be an asymmetric projectile. Also something that is launched from the ground like this, and we forget about everything up to there, so that when you get to the end, the final velocity is just horizontal. So those would be symmetric. And can you think of a different way, like a different kind of each of these is half of a symmetric problem. So what's another kind of asymmetric one that would be different? Claire?
Well, and like the starting elevation is higher.
So, okay, so it goes like this, but then like that? Yeah, so you can have the starting elevation higher than the ending elevation. What's another one? You can have that from right to, you mean from right to left instead of left to right?
Yes.
Oh, you
Higher
mean
elevation.
like this? Yeah, so that could work. Start there and there. What's another kind of variation on this? And the directions could be different. I can think of one where I would start at this elevation and end at that higher elevation, but it'd be kind of a different problem than this. Could be this, where it's just still going up. I don't know. That seems a little bit different. So that would not quite be to its high point yet. I don't know. So those are some possibilities. And all this could be reversed too. So we could go right to left, left to right. And then the next question was, if I'm going to do this, what I do as the teacher is I start to think about all the different variables that are involved in these situations, and then I'll give you a few and you have to figure out the others. So I'll make a little list here. I'm going to do sort of x dimension, y dimension, and then over here, I guess I'll just call this velocity. So I'll do the velocity part. So some variables that I could give you or could ask for would be v0, v, theta. I'll call it theta and theta, or theta 0 and theta. And what I mean by that is I could ask you what this is. That would be v0. Or I could ask you what this is. That would be v. Or I could ask you what this angle is. That would be maybe theta 0. Or I could ask you what this angle is. That could be theta. So with regard to just velocity, meaning the vector that's tangent to the path at any point, there are really two components to that. There's the angle and there's the magnitude. And this would be the initial magnitude, this would be the initial angle, this would be the final magnitude, final angle. So in the x dimension, what are some variables that you might have to either be given or find? So I'm going to put little equal signs there, like I'm going to write some answers. I didn't leave enough space. Yeah, so I can do delta x. So that's one thing in the x dimension. What's another variable in the x dimension? Time? Yep. And how many more are there?
Could you do velocity? Or should you just leave that to
Yes,
velocity?
I could do velocity. Now, would that be initial velocity or final velocity or both or what?
Average?
So in this, I'm just going to call it Vx because the initial velocity and the final velocity and the average velocity in the x dimension, they're all the same. So that's it. What's the acceleration in the x dimension? There isn't one. So this is it. There are only three variables that we could possibly have to deal with in the x dimension. Y dimension, I'm going to go ahead and do all these. I could say delta y, so that would be the y displacement. Could do t. That's the same. So t, whether I'm talking x dimension or y dimension, t is the same. Then v0y, and then vy, because those are going to be different. So if I had the starting point right here, the y velocity be v0y, and then this ending y velocity would be vy like that. But if I did vx, it'd be the same in both cases. Yeah.
Can you say acceleration?
Yeah, acceleration, and I know what that is. What's that? Negative 9.8. So that's something I would never have you solve for, but that's something you'll always be given. And I think that's it. I mean, I guess you could do average velocity too, but I don't usually put that on the list here. So if I wanted to make up a problem, let's make up a couple of problems. I just start thinking about things I could give you here, and then what could you find from them? Does anybody have an idea? Like what's something I should give you to begin with? Pick one of those variables. No, I'll make up a number. And we'll go from there. So which kind of displacement? Do you want x displacement or y? What did you say? X. Okay. So I'm just going to make up one. I'm going to make this 5 meters. So we have an x displacement of 5 meters. That means, Oh, I'm sorry. Thank you. Nobody's paying attention. That means wherever this starts, it's going to wind up 5 meters to the right of that. All right. So what do you think we should be looking for here? Does anybody have an idea? Like anything that would be fun? What can we try to find in the end?
V0.
V0? So, okay. So regular old V0, not Vy0? Okay, so we're looking for this. And I want this to be useful. So
Delta Y.
delta y, let's see.
Oh, that'd be useful later on.
I think we could do delta y. Do you want it to be positive or negative? It could be either. I think we could work either out.
Positive.
Positive? Okay.
Easy.
All right. Is positive confusing? I don't know if positive would be confusing. Negative could be. So
That's
delta y
awesome.
is going to be 20 meters. Oh, you're saying because negative is confusing?
Yeah.
No, let's do negative then.
Negative will take the.
Negative will be a better test. Like we need to do the confusing stuff before you have the test. If you can handle that, then you can handle my easy test questions. All right. So what we know so far is this thing is going to be moving 5 meters to the right, and it's going to fall down. It's going to wind up 20 meters lower than it was before.
How does delta Y help? Does it give us
I don't know. I'm sort of figuring this out as I go. So we know the x and y displacement.
How fast does that have to go that?
Right, so should we do time?
Yeah.
All right, so let's say 4 seconds. We can make it, does anybody have a favorite time you'd like to do?
10 seconds.
10 seconds. You can pick an easy one, 11 seconds.
Five more seconds.
11 seconds. So that's the same in both dimensions. All right, so, ooh, okay, so this could be hard. I think we probably got everything we need for this. Let me think about this. So we're looking for initial velocity. And if we want V0, it would be helpful to be able to find the initial x component and the initial y component. Based on what we have, can we get the x component from this? Can we get Vx? You're saying yes, Claire? Yeah, because in the x dimension, there are only these 3 variables. It's kind of like distance equals rate times time. So that's no problem. We can get that. And then in the y dimension, do we have enough information to get V0y? We want to know initial y velocity. We've got y displacement. We've got time. We've got acceleration. What formula could we use to get the initial y velocity there? I know of one.
I equals VG
Say that again, Riyam?
plus half times time.
I heard the half, so I think what you're saying is delta y equals V0t plus 1/2 at squared. Yeah, so we could plug in negative 20. V0y, that's what we'd be solving for. And 1/2 a t squared, so we could find it. All right, so I'm going to take a picture of that, and maybe I'll send everybody, minus that, send everybody an email later of this, and then let's come up with one more.
Oh, are we not solving this?
Not right now, because I want to move on with other things, but just giving you some examples that maybe we could try out, and giving you some insight into what I do when I'm making tests and stuff. So, all right. Let's do, I'm going to choose this one. Let's do this final angle. That's what we want to find. Anybody want to pick another variable that you like, maybe that we haven't used so far? Vx. Okay, what do you want Vx to be? I'm going to make it negative something. You choose the number. Negative 8.5 meters per second. All right. So that's going to be helpful because in the end, if we're trying to find this angle, this is drawn wrong, by the way, since x is going to be negative the whole time. The thing is going to be landing like this, or maybe it might actually still be going up. I don't know, but we can figure that out. So it's coming in like this. It's going to have a y component and an x component, and we're going to want to figure out that angle or this angle. We can really do either one. I guess this is probably the angle that we'll want in the end. So right away, we've got half of what we need. This is just something else we're going to need. So I don't want to give you that because that would be way too easy. So pick some other variable and let's see if it would be useful. What's that? Time. Okay. How many seconds? Can't be negative. 13 seconds. So something's in the air for 13 seconds, and its x velocity is negative 8.5 the whole time. I'm going to pick the next one. I'm going to give you the initial angle. Actually, I don't know. That might be kind of a pain. Let's do initial y velocity. You want it to be positive or negative? Might be weird if it's negative, but it could be. Should we do negative? Positive? No. Somebody pick one. Positive. What? 2. 2? All right, 2. All right. So that's going to be 2 meters per second. That's the initial y velocity. And I think we're done. Yeah, I don't think we need any more. We've got the initial y velocity. We know how fast it's going upward in the beginning. We know the acceleration. We know the time. So from that, we could definitely get the final y velocity. What formula would give us final y velocity if we have initial y velocity, acceleration, and time? Yeah. V equals V0 plus AT. So that could give us that. And then once we have Vy and Vx, how do you get this angle from those two? Yeah, inverse tangent of those. All right, so there's the other problem. And if you want to come up with your own, come up with one with some different variables in there and send it to me. And I'll probably provide solutions to these, or maybe we could do them tomorrow at Wednesday week. All right, unfreeze, otherwise known as thaw, I guess. Questions about the homework? So the homework was to do that practice test number 2, and the homework for tonight is to do the problems on the back. And I realized, looking at my answers, that I came up with this answer key a long time ago, and I think I've gotten better and better at explaining things in physics, and if I were to redo this answer key, I would redo it better. Yes, Claire? Number what, 2? 2, okay. So, can a projectile's y velocity affect the projectile's x displacement? Why or why not? So, I've been saying over and over that if you want to know what's happening in the x dimension, then you really can separate that from what's happening in the y dimension. So, if you want to know how high something goes, you can just deal with the y dimension only. If you want to know how far something goes horizontally, then you deal with the x dimension. But this is kind of an exception to that. Let's see if my stuff is up right here. It is. So this is, can the y velocity affect the displacement? And my answer is yes, a greater y velocity will extend the time aloft, giving more time for horizontal travel. So it's an indirect kind of thing. If you shoot something at, let's see, you have this y velocity, 4 meters per second, and this x velocity of 3 meters per second. And that gives you, I guess this would be 5. I accidentally did a 3, 4, 5 triangle. That would give you this kind of an angle. And let's just say it goes this far. I can keep that the same, and I can increase the y velocity. I don't know, I kind of don't want to mess up my picture, but I'll make it twice this. So now it's 8 meters per second. And I don't know if that's any well-known kind of a triangle, but if this is the x and this is the y, then now this would be the new actual v. And since this velocity, this x velocity, I've kept the same, all I've done is I've changed the y velocity. It's still going to keep going this way just as fast, but what this is going to do is it's going to go higher and stay in the air for longer. So it's going to give it, it's going to probably go out of my picture and come down way over here. So while increasing this doesn't have any effect on the x speed, increasing this does make it stay in the air longer. And that allows it to move at that same speed in the x dimension, but for more seconds before it touches down. Claire, does that make sense?
Yeah.
Okay. Other questions? Number 3, I would like to just take this moment to redraw this, because I've been using, or I used in this example, the parallelogram method of drawing vectors, which is what I was taught and I kind of used through college, but since then I've decided it's so much better and more consistent and easier to use head to tail method. So here's what I should have done. Number 3 says, describe the object's direction of travel. It's got an x velocity of 5, a y velocity of -5. This is what I should have done. Should have drawn an xy grid, and I can draw the x component first, 5. And then I can draw the y component, -5. So that's Vy, this is Vx, and then the resultant, when you put them together, is like that. And this is going to be a 45-degree angle. So it'd be 45 degrees below positive x, or 45 degrees to the right of -y. And I could have also drawn it like this. Instead of drawing the x first and then the y, I could draw the y first. So there's the y. And I'm just writing 5. I'm not writing -5 because my picture shows it downward. So I think it's confusing to say -5 downward, because that sounds like upward. And then this is the x velocity. Vx equals 5. And then this would be the v. So it's the same either way. You get the same answer. Just in case you keep hearing me say parallelogram method, I'll just really briefly show you what I mean by that. All I've really shown you is rectangles, but suppose you have this vector and you want to add this vector to it. With the head to tail method, this would be the resultant. But with the parallelogram, you start these two together, tail to tail, and you can go like this. So here's one vector. Here's the other one. And then you draw a parallelogram like this. This parallel to that, and then the diagonal, that's the resultant. So that's the way I was taught to do it in college. I kind of like to do it sometimes, because if I'm saying, here's a ball, this is one component of its velocity, this is another component, this is its actual path, all the vectors leave the ball, which is kind of nice. If I'm drawing a ball like this, then this one's coming out of the ball, and so is this, but this one's just out in space over here. So I think that's why I draw it like that sometimes. Other questions about page 1? I don't think I really, oh, I guess I did circle this. A lot of people asked me about number 4, and the answer was supposed to be B. The only thing that matters is if you're considering how long it takes to get across a river, and in order to go across the river, you're traveling in the y dimension, all that really matters is the boat's y velocity component, assuming that the current is not in that dimension. Questions? Okay, so yesterday I didn't feel like I gave people enough time to take their tests, but today I think I'll have plenty of time. Let me just see if there's anything else I wanted to read. It's yesterday. Oh, here's an extra non-orthogonal river problem for anybody who wants some extra practice. It's right here. I made a little video. This is an answer. We did it as a warm-up last term, but I'm doing this warm-up today instead. And then for practice, just do the rest. Here are the solutions and a few videos over the answers. Hopefully they're recent videos. I've gotten better. And that's it. So people who are remote and you want to retake the test, stay on here and I'll assign that for you. But first I'm going to pass out the test here for people who are taking stuff. Everybody else can take off.